Okay, so we're going to look at this topic, which is called travel graphs. So in looking at this topic, we'll look at 3 examples, then 2 questions will be given that will serve as an exercise. So we'll start with the first example. So this will be example number 1. The diagram below shows a speed time graph of the car journey. So this is what we have here. Then let's see, we have that. So we have speed this side, then we have time down. Let's see what they're asking us to find. So they're saying the first one, part A, find the acceleration during the first 5 seconds. So allow me to do A from here. So acceleration is given by the final velocity minus the initial velocity over time. So the final velocity is what? So the final velocity is here. This is where the final velocity is, the highest number, which is a 30. Then the initial velocity, it started at 0. Then the time it took, since it has said in the first 5 seconds, you put 5. Then 30 minus 0 is 30. And 30 divided by 5, we get 6. So the answer will be 6 meters. The units of acceleration is meters per second squared. So that one has been found, the first one. Then we're going to proceed. We look at part B. If the total distance traveled was 825 centimeters, find the value of t. So how do we find distance? So distance is found by finding the area under the graph. Now I want you to look at this graph. The area here that I'm shading, what shape is this graph? So the shape of this graph is a trapezium. So to find distance, so we're looking at part B. To find distance, we're going to use the formula for the area of a trapezium, so which is half, then A plus B height. So this becomes, now they've told us to say the distance is 825. So I'm going to put 825 where there's distance, then this will be half. Then we're going to say A plus B. So if I count from here, if I say this is my A, then this is my B here. So if I count from this point to that point, it's between 5 and 15. The difference is 10. And plus B from 0 to t, so it will be t minus 0, which is just t. Then the height. So the highest point, if we look at the height is 30. Then from there, what are we going to do? So we proceed. We're going to say 825 is equal to 2 into 2 is 1, 2 into 30, that is 15. Then 15 times 10, we are now multiplying what is outside with what is inside, is 150. Then 15 times t, that is 15t. Then what I'm going to do is I'm going to say the 150 will cross the equal sign. So at here I have 825. The 150 will become negative 150. And this side I have 15t. What is 825 minus 150? So that one we have 675. So is equal to 15t. Then I'm going to divide by 15 both sides, even this side by 15. So that goes, and the value of t will be equal to, now I'm going to say how many times does 15 go into 675? So 15 goes into 675 45 times. So the value of t is 45 seconds. So the value of t is 45. Since t is time, right? I want you to take note. The units are also very important. So t is time here, and the time is measured in seconds. So that is the value of t. Then now we're going to look at the other question, which is saying find the average speed for the whole journey. So So we find the average speed for the whole journey. Now, how do we find the speed? It's simple. So we're looking at C. Speed is found by saying distance divided by time. So speed is equal to the distance they've given us. It's 825. And what is our time? Our time that it took is for the whole journey. We found t here. T was 45, so the time is 45. Then how many times does 45 go into 825? Now remember, we're not allowed to use the calculator, so you simplify. So you're going to say we can start with 5. 5 into 45 goes there 9 times. Then 5 into 825, it goes there 165. So meaning I have 165 here, then divide by 9. Then I can say 9, or I can say 3 into 9. 3 into 9, that is a 3. 3 into 165, that is 55. So meaning the answer here is going to be 55 over 3, because we don't have a number that will go into both 55 and 3. So, and we are not going to leave it as a decimal, so we'll leave it as a fraction. 55 over 3. The units are meters per second. So this is the answer. So 55 over 3. Right, I hope this one is also clear. Let's look at another example. Let's look at another example that we can call example number 2. So this is the second example. The diagram below shows a speed time graph of a 100-meter sprinter who accelerates uniformly for 3 seconds until he reaches a speed of 12 meters per second. He maintains the speed for 7 seconds and then uniformly retards for a further 4 seconds. Alright, so this is the journey that they were explaining. Now let's look at the questions. First question, calculate the acceleration during the first 3 seconds. So let me find acceleration here. Remember, acceleration is given by final velocity minus initial velocity over time. Acceleration will be equal to the final velocity here was 12. Then the initial velocity there is 0. It started at 0 where it started from. Then the time, they want 3 seconds. So 12 minus 0 divided by 3. Okay, so this will be 12 divided by 3, which will be 4 meters per second squared. So these are the units. Meters per second squared. Second question, they want us to find the retardation at the end of his race. Now, retardation is found when something is coming down here. This is where retardation is. So coming down. So we're just looking at this distance. So this diagram. So this is where retardation is. So now, this is how we find retardation. Retardation is defined as negative acceleration. So this is how you find it. So you say negative acceleration is equal to v minus u over t. So negative acceleration. So now, negative acceleration is equal to, now the final velocity, now check here, it started from here. This is where our initial velocity is. Our final came here. So our final velocity is 0. If you check here, this is where the 0 is. So our final velocity is 0. Our initial velocity is 12. It started at 12. The time it took, we just say what is the distance between 10 and 14. So the distance is 4. Then I'll say over 1, cross multiply. Then what is negative 1 times 4? So this is negative 4a. Then 0 minus 12 times 1. This will be negative 12. Then divide by negative 4, divide by negative 4. So that goes. Then a is equal to negative 4 into negative 12. That's positive 3 meters per second. So now instead of saying A, now I'm going to call it retardation. So I'll say retardation is equal to 3 meters per second. So retardation and acceleration have got the same unit, so you just use the same unit. Right, now let's see the other question. Calculate the distance covered in the first 10 seconds. So we're looking for this distance from 0 all the way to 10. So this one from here then coming down. So again, if you check, this is the shape we're looking at. Hopefully you'll be able to see. This is the shape we're looking at. Again, this qualifies to be a trapezium. In most cases, the diagrams that I've seen are trapezoids. So this is a trapezium, and you just have to use the formula of calculating area of a trapezium. So how do you find the area of a trapezium? So to find distance, we're going to use the formula for the area of a trapezium, which is half, then A plus B height. So that is the formula we use to find the area of a trapezium. Then from there, we're going to say we need to find distance. So this will be equal to half our A. So let me say this is our A, this is our B. So from this point to this point, so it will be between 3 and 10. 10 minus 3, that is 7, plus our B from 0 to 10, that is 10. Then our height is 12. Then 2 goes 2 into 12 plus 6. Then what is 7 plus 10? 7 plus 10 is 17. Then the 17 is going to multiply the 6. What is 17 multiplied by 6? So 17 times 6 we get 102. So 102. So distance is measured in meters. So the units should be meters. So that is how you can find that. Now let us do another question that is going to help us cement our understanding. So this is another question that we can look at. So this question is saying, the diagram below shows the speed time graph of a particle. The particle started off from rest and accelerated uniformly for 10 seconds. It then traveled at a constant speed for 20 seconds and then decelerated to rest. So this is the diagram that we have here. Alright, now let's look at the questions. So we have the first question here, which is saying find the speed v the particle reached if its acceleration was 2 meters per second squared in the first 10 seconds. Right, so they have given us acceleration and they want us to find the speed. So let me just do it here. Remember, acceleration is given by v minus u over t. Alright, so now they've given us to say the acceleration is 2. Alright, then the v we don't know. This is the v here. Then initially it started at 0. Even if there is no 0, we know it started from rest. The time it took was 10 seconds. So this is going to be over 1 cross multiply v minus 0, that will be v, then 2 times 10. So our v will be equal to 2 times 10, 20 meters per second. So this is our v, meaning we found that. Now that that has been found, we proceed into finding part B. Given that the total distance covered was 750 meters, find the value of t in the diagram. So now how are we going to find t? Now to find t, so if I do it from here, find t, I'm going to use the formula for distance. Now if you check out this diagram, this is also a trapezium. So what we can say, this is A, this is B. So now from here we're going to say area of a trapezium is equal to half, then A plus B height. So the distance they've given us that it's 750. So while there is distance, you put 750. Then you say half. Our A, the distance from there to there is 30 minus 10, which is 20. Then our B, from 0 to T, it is just T. Then our height, V, we now found V to be what? To be 20. So 2 into 20, it's 10. Then from there, I'm going to say, I have 750 here to be equal to, what is 10 times 20? 10 times 20 is 200, plus 10 times T is 10T. So I have 750 here is going to subtract 200, and here I'll remain with 10T. 750 minus 200, I'm getting 550. 550 is equal to 10T. I'm going to divide by 10, even this side by 10. So the 10 goes, T will be equal to 10 into 550, so that is 55. So T will be equal to 55. So I'm finding T to be 55 seconds. So T is time given in seconds. So 55 seconds. Now that has been found. We now answer the other question, which is saying, what was the speed at 40 seconds? So how do we find the speed at 40 seconds? Now this is easy. We know that speed is given by distance over time. Alright, so this will be equal to, the distance is what? Now the distance that we found is, in fact they gave us this distance. We just use this one. We didn't find it. 750. Then time, they want us to use the 40. So now what we're going to do is, the 0 and the 0 are going to go. Then how many times does 4 go into 75? So 4 into 7, it goes there one time. Then it leaves a remainder of 3. 4 into 30. So we have 4 into 35. So that is 8. Okay, remainder. Okay, then this will be 0.75. So it will be 18.75 meters per second. You can also leave it as a fraction, but this one I saw that I would simplify it, so I've just simplified it and I found that one. So that's how you can go about that. And I'll give you 2 questions that you can try. So the first question is this. I want you to follow it where it's coming from. Let me just do this so that I show you where it's coming from. So this is where it is starting from. So I hope you've seen this part. This is where it's coming from. So if you read this part, then I take you down. This is a diagram. Then we go and look at the questions. These are the questions. Yes. Then we go to the last question. The last question, I take you up where it's coming from. So the last question is starting from, where is it? The last question is starting from here. So hopefully you are able to see where it's starting from, the diagram below dash dash. Then that's where it's starting from. Then you check out the diagram. This is the actual diagram. Once you see the diagram, then you look at the question. So these are the questions which are being asked. So once you answer these, then you are good to go on this topic.